عشان مش قادر يتفوت نسجل له يوم بعد. Okay. Part C2, we note R0 as the rate of disappearance of H3O plus at the instant t equals 0, and R1 that means the rate of disappearance of H2O plus at the instant t1 equals 5 minutes. Among the relations given below, choose the correct one, justify graphically. R0 bigger than R1, R0 smaller than R1, R0 equal R1. Which one is the correct choice?
R0 أكبر من R1.
R0 bigger than R1. Yeah. Why?
عشان التانجنت slope.
Because the rate decreases.
بيطلع الريت للA 0.45 والريت للB 0.35. فالريت للA أكبر من الريشيو للB.
Okay. Then rate at t equals 0 bigger than rate at t equals 5 minutes because the rate of disappearance of a reactant decreases with time. طيب. Justify graphically. Graphically بيصير بالشكل التالي. R0 bigger than R1 because graphically the rate of formation of Zn2 plus is equal to the slope of the tangent at on the curve concentration Zn2 plus equal Fe at the point of axis E. This is the definition of the rate graphically. We draw on the curve 2, 3 tangents, and according to the graph, the slope of the tangent on the curve is maximal at t equals 0. The slope is maximal at t equals 0. Then it decreases with time. Therefore, the rate of formation of Zn2 plus is maximal at t equals 0. Then it decreases with time. Heck, we can explain graphically the variation of the rate with time. 3.3, last part. Determine graphically the half-life time we have. Solution. We should write the definition of the half-life time is the time needed for the formation of the half of the concentration Zn2 plus at infinity. At t half, concentration Zn2 plus equal concentration at infinity over 2. Concentration at infinity we have calculated it equal to 0.25 over 2 equals 0.125 mole per liter. According to the graph, this is 0.125. The abscissa of this point is the half-life point. T half equals 240 seconds. We write according to the graph T half equals 240 seconds. إذا هيدا exercise فينا ناخده كتايب نموذج كيف ممكن تيجي الأسئلة بالامتحان على هيدا الدرس. Now, exercise of chapter 1. Exercise 1. Given the reaction A plus 2B gives C. راح اكتبون انا وما تنقلون انتوا وراي، ببعث لكم يوم تنقلون على رواق بالبيت. The initial composition of the system being is 0.45 mole of A and 0.70 mole of B and 0.1 mole of C. C, the product is not 0 at t equals 0. We have 0.1 mole at the beginning of the reaction. The evolution of the number of moles of C with time is studied. Number of moles of C, the product. Identify among the curves given below the one that corresponds to the system. First, the system starts with the variation starts with the number of moles of the product C. Then the curve should be ascending. Yes. Graph A or graph B. Graph C represents the reactant because it is descending. Then graph C is not correct.
آه.
Graph A or graph B, which one is the correct?
بنجيب الريت.
This depends on the path shape of the curve. نحن أخذنا بالshape of the curve, we should identify remarkable points, which are the initial point, the half-life point, and the maximum limit. In this case, we have no given about the half-life time. Then we should identify two remarkable points, the initial point and the maximum limit. The initial point واضحة. At t equals 0, number of mole of C equals 0.1. The initial point is 0.1. But the maximum limit, we should calculate the number of mole of C at the end of the reaction. How? We will see. هلا بدنا نشتغل على الأوبن بورد. Okay. Exercise 1. We have reactant A, N0 equal 0.45 ولا 45 mole plus B N0 equals 0.7 mole. We obtain C. C is not 0 at the beginning. N0 equals 0.1 mole. These are the given. The equation, balanced equation A plus 2B give C. Now, to calculate the number of mole of C formed at end of the reaction, we should use which reactant, A or B? We cannot. No, we should identify the limiting reactant. To identify the limiting reactant, we calculate the ratio for each reactant. Ratio of A equal N0, initial number of mole of A, over stoichiometry, which is 1, equals 0.45 over 1 equals 0.45 without unit. Ratio of B equal N0 of B over stoichiometry, which is 2, equals 0.7 over 2 equals 0.35 without unit. We compare the two ratios, we find that ratio of B less than ratio of A, therefore B is the limiting reactant. أما 13 ماشي، يعني الكل موجودين، ما في غياب. ماشي؟ بنكفي. Now, according to the stoichiometry of the reaction or stoichiometric ratio, we have number of mole of C formed at infinity, at end of the reaction, over stoichiometry 1 equal N0 of limiting reactant B over stoichiometry 2 equal N0 equal 0.7
0.35
over 2 equals 0.35. This is the number of mole of C formed at end of the reaction. But number of mole of C at end of the reaction, that means at infinity, equal and 0 of C plus number of mole of C
Form.
formed at infinity.
Yeah, 0.1 plus 0.35.
Bravo. 0.1 plus 0.35 equal
0.45.
0.45
يعني جراف B.
mole. This is the maximum number of mole of C. The maximum limit should be 0.45. Then خلينا نبدا على صفحه جديده لانه ماشي الساعه.
Graph B is the accurate one.
هلا the characteristic of the graph C. ده راح اكتب هون. The curve NC equal FT has the remarkable point. يعني نحن عم نحدد وبعدين نشوف which one is. Initial point
0 point.
which is of coordinate times 0. Constant number of mole is not 0, it is 0.1. Half-life time, we have no for half-life time, so the maximum limit
Over 2. Over 2.
is constant number of mole of C at infinity equal 0.45 mole. Now, which curve has the following, have this characteristic? It starts from 0.1 and has maximum number of mole 0.45. Graph B. Then in graph C, the curve is ascending in graph B. In graph B, the curve is ascending, starts from 0.1 and has a maximum limit
at 0.45.
45 mole. Then this graph
is the correct one.
Represents the variation of this system. Okay? في شيء
Okay.
واضح؟
واضح.
حدا عنده سؤال عليها؟
No.
Okay.
No.
Now, exercise 2. Okay. Exercise 2. نرجع ل exercise. Exercise 2 هو بيشبه لدرجة كبيرة الشرح اللي موجود. Same reaction, same experiment, but different volume and concentration. الأسئلة هن ذاتهم. يعني اللي فهمان الشرح أو بيرجع للشرح بيقدر يحل السؤال بكل سهولة. Yeah. Reaction between I- and H2O2 in acidic medium. At the instant T equals 0, a solution S is prepared by mixing the following solutions. 10 milliliters of potassium iodide solution Ki of concentration C1 equals 0.1 mole per liter. 2 milliliters of sulfuric acid H2SO4 of concentration C2 equal 1 mole per liter. 10 milliliters of hydrogen peroxide solution H2O2 of concentration C3 0.5 مول per liter. خلينا نكتب الجبن وبنرجع على السؤال. إذا we have K plus I minus solution of C1 equals 0.1 mole per liter and V1 equal 10 milliliter plus H2SO4 of concentration C2 equal 1 mole per liter and V2 equal 2 milliliter plus H2O2 of concentration C3 equal 0.5 mole per liter and V3 equal 10 milliliter. We obtain a solution, a mixture S of V total equal 22 milliliter. Sum of the three volume 10 plus 2 plus 10 equal 22 milliliter. Now, the equation or given, the net equation of the reaction is 2I minus plus H2O2 plus 2H plus give I2 plus 2H2O. We follow the evolution of the reaction by titration of formed iodine at each instant by sodium thiosulfate solution and A2S2O3. Exactly as the experiment studied in the code. نفس experiment. The following table shows the concentration of I2 formed at each instant given. At t equals 0 is not given, but we should know that the concentration of I2 at t equals 0 should be equal to 0. 1.
0.
Determine the initial concentration of each reactant in the mixture. Okay. Part 1. To calculate the initial concentration first, we should calculate the initial number of moles for each reactant. And 0 I minus equal and 0 of Ki equals C1 times V1, C1 0.1, V1 equal 10 milliliter times 10 minus 3 to transform it to liter, equal 1 times 10 minus 3 mole. We divide the initial number of mole of I minus by the total volume to obtain the initial concentration of I minus and 0 I minus over V total. And 0, 1, 10 minus 3 over V total 22 times 10 minus 3. And 1 over 22, the calculation, 1 over
تطلع 0.045.
0.0
45.
45
5.
mole per liter. Pick up here add. Okay. Now نفتح صفحة جديدة. The same for the other reactant. N0 for H plus equal N0 of H2SO4 multiplied by what? We have 2H.
By 2.
Each H2SO4 give 2H plus, then N0 of H plus equal 2 N0 H2SO4 equal 2 times C2 V2 equal 2 times C21 V2 2 milliliter times 10 minus 3 equals 4 10 minus 3 mole. Initial concentration of H plus equal N0H plus over V total equal 4 10 minus 3 over 22 10 minus 3 equal 4 over 22
plus 0.18 mole.
0.18 mole per liter. Now, N0 of H2O2 equals C3V3 equal 0.5 times 10 minus 3 equals 5 10 minus 3 mole. Concentration, initial concentration of H2O2 equal N0H2O2 over V total.
تطلع 0.23
over 22 10 minus 3 0.23
23
mole per liter. Okay. Let's take part 1, the initial concentration for each reactant. 2, show that I minus is the limiting reactant. Okay. 2, we should calculate the ratio for each reactant. Ratio of I minus equal N0 I minus over stoichiometry 2. N0 I minus, we have calculated it equal to 110 minus 3. 110 minus 3 over 2 equal 5 10 minus 4. Ratio for H plus equal N0H plus over stoichiometry 2 equal N0H plus equal to
4 times
equal to 4 10 minus 3 over 2 equal to 10 minus 3 ratio without unit. Now ratio for H2O2 equal N0H2O2 over stoichiometry equal N0H2O2 5 10 minus 3 over 1 equal 5 10 minus 3. By comparing the three ratios, we find that ratio of I minus
H plus
less than ratio of H plus less than ratio of
H2O2.
H2O2. Then
I minus
I
is
minus
limiting.
is the limiting reactant. Okay. Now,
3.
part 3,
Yes.
determine the concentration of iodine formed at the end of the reaction. New page. 3. To calculate the concentration of I2 at the end of the reaction, first we should calculate the number of mole of I2 formed at the end of the reaction according to the stoichiometry using the limiting reactant. According to the stoichiometry of the reaction, number of mole of I2 formed at end of the reaction, upper 1 equal N0 of limiting reactant I minus upper 2. So 5, 10 minus 4, this is the initial number of mole of I minus, or 1, 10 minus 3, let's check, 1, 10 minus 3, sorry. Then 1, 10 minus 3, over 2 equal 5, 10 minus 4 mole. This is the number of mole of I2 at end of the reaction. Concentration of I2 at infinity at end of the reaction equal number of mole of I2 at infinity over V total equal 5, 10 minus 4 over V total 22, 10 minus 3. 0.5 over 22.
0.0227.
0.0227 mole per liter.
Per liter.
This is the concentration of I2 at the end of the reaction. Now, before the titration, we pour the taken volume of the mixture S in another mug containing 150 ml of icy water. Indicate the role of this step. Why we put the
stop all the reaction
in icy water? To stop the reaction. 4, to stop any reaction other than
titration.
The titration reaction. إذا هذه مثل ما اتفقنا حفظ. Why? We will see in the next chapter, chapter 2, kinetic factor.
Okay.
5. On بدنا ننتبه relation. Show that at each instant, concentration I minus at instant t equals 0.045 minus 2I2 at instant t. Connect to the relation. Concentration of I minus at instant t equal 0.45 minus 2 concentration I2 at instant t. نتأكد مضبوط هيك 0.045. Okay. 0.045 at instant t. First, I minus is reactant or product?
I minus is a reactant.
Is a reactant. Then at instant t means that concentration of I minus at this instant. I2 is a product at instant t means formed at instant t. We should determine the relation between left of the reactant I minus and formed of the product I2 at each instant. Number of mole of I minus left at instant t equal N0 I minus minus N I minus reacted. Now, according to stoichiometry of the reaction, what is the relation between I minus reacted and I2 formed? Number of mole of I minus reacted
equal 2N I2.
2 equal number of mole of I2 formed at instant t. That means number of mole of I minus reacted equal 2 number of mole of I2 formed at instant T. We can replace number of mole of I minus reacted by 2 number of mole I2 formed in this relation at each instant. Then number of mole of I minus at instant T equal N0 I minus as we have said, we replace N I minus reacted by 2 N I2, 2 N I2 formed at instant T.
هلا بنحوله ل concentration divide by V.
Bravo. This is the relation. This is the relation in number of mole. Divide by V. Number of mole over V is concentration of I minus at instant T equal N0 I minus over V initial concentration of I minus. Initial concentration of I minus 2 number of mole I2 over V concentration I2 at instant T. We replace initial concentration of I minus by its value. Initial concentration of I minus, we have calculated it.
45.
ليه ما عم تفتح؟ على كل حال equal
0.045. 0.045.
خلينا هي 0.045. We replace I minus initial by 0.45. The relation becomes 0.045 minus 2 I2 at instant T. Concentration of I minus at instant T. This is the final relation. Now,
number 6.
Number 6. Number 6. Complete the above table by calculating the concentration of I minus ions at each instant. We add another line, which is concentration of I minus at each instant, but we start from 0. هون بدها تاخد شوية وقت. Part 5 or part 6. We have 0. نشوف كم 1 2 3 4 5 6. 1 2 3 4 5 and 6. Concentration I2. Now concentration I minus 0. بدي انقل البقايا بس 3 5.2. اذا فيكم تنقلوني اياهم اذا تقدروا تشوفوهم. 3 5.2
بيرجع 5.2.
على 3 7 8.2 7 8.2
بيرجع 8.2
9.2 وعلى 6
بيرجع 9.2 بيرجع
10.
10.
Okay. The relation is I minus equal 0.045 minus I2 times 2. This is in mole per liter, in millimole per liter, or times 10, times 10 minus 3. بتصير times 10 minus 3 وهون times 10 minus 3 بتصير بضربها بقلب بتصير هذه 45 then at equal view 45 minus 2 times 3 45 minus 6 that means 39 now 45 minus 10.4 45
34.6.
10.4 34.6
Yes.
45 minus 14 30 minus 14 for 31
Yeah.
now say 45 minus 2 times 8.2 16.4 equal 28.6 now 45 minus 18.4
26.6.
26.6 and
25.
25 minus 20 25 this is the new line represents the concentration of I minus times 10 minus 3 mole per liter.